Hi, this is going to be a little video to teach you how to find the molar mass of a substance, no matter what it may be. It may be an element or a compound. Let's flash back to what you learned early in this semester, and that was that on your periodic table we have the atomic number, which is the whole number, and that tells you the number of protons and electrons in an atom. And we also have the atomic mass. And the atomic mass is measured in AMUs, and that number is a weighted average of every known isotope of that particular element, taken together as an average. Now, in chemistry, you're not going to be working with the mass of one individual atom. You're going to work with always a mole, and that mole can then be converted to other amounts, like grams and particles, and eventually even volumes. So on your periodic table, if I asked you to figure out the mass of 1 mole of an element, you would go to your periodic table and look it up. So say, for example, you went to a periodic table and you would look up the mass of oxygen. So you go to your table. Oxygen is atomic number 8. On your periodic table you would find two numbers, of course. Oxygen is atomic number 8, and the atomic mass of oxygen is 15.99. Now, 15.999. One thing you have to be aware of is that in this course, to keep things consistent all the way through, every single time you find the molar mass, or the mass of any element, I want you to do it to 2 decimal places. That means count the first 2 over, check the next one. If the next one happens to be 5 or above, you're going to round it up. Therefore, the molar mass of 1 oxygen atom, 99 would round up to 100, so we'll bump it up to 16 for 1 oxygen atom. So let's go back and do these 6 examples here on the page. The first one is SB, antimony. Antimony is element number 51. Go to your periodic table, look it up, and you will see that on your table it's 121.76 AMU, which we're going to translate then into a mass for 1 mole, and we're going to write it as 121.76. In the units of molar mass, there would have to have 121.76 grams for 1 mole to be the equivalent to be 1 mole of antimony. So go to your periodic table and find carbon. Carbon's number 6. And the atomic mass is 12.011, which you would round, keeping to 2 decimal places, 12.01, and that's the grams in 1 mole, grams per mole. So if I asked you to give me 1 mole of carbon, you could give me 12.01 grams, and that's the equivalent. Se is selenium. Selenium is number 34. On your periodic table, the atomic mass is 78.96 AMU, so that translates to 78.96 grams in the equivalent of 1 mole. Now when I write that unit, it's very messy, it's hard to tell, but you can write it either like this, grams per mole. When we do all of our conversions, it's much preferable for you to write the molar mass, say selenium as an example, 78.96 grams per 1 mole. And by the way, that could also be written upside down for future reference. That's the same thing as saying 1 mole is the equivalent of 78.96 grams. If, when you're required to make a conversion, to have the grams go on the bottom, remember that everything is based on 1 mole. 1 mole contains 6.02 times 10 to the 23rd particles, and 1 mole contains a certain number of grams based on what the substance is. Each substance is different. To finish these last two, sodium, look at your periodic table. It's 22.99. So if you wanted 1 mole of sodium, you would need a 22.99 gram sample. Iron. Iron is 55.845. When you round properly, you will get 55 point, rounding the 5 up, the 4 is going to go to a 5, so 0.85 grams per mole. And xenon, which is a noble gas, not very reactive, the molar mass of xenon, if you wanted 1 mole, you would need 131.29 grams for the equivalent of 1 mole. And all those numbers came from your periodic table. All those numbers were rounded to 2 decimal places, and that's for consistency without the entire course. So please always round it 2 places so that every answer key that you check will match your calculations. So if you're going to do a molar mass of a diatomic molecule, remember that diatomic molecules occur in sets of 2s. So if you're ever asked to find the molar mass, say this one in your booklet, chlorine, that's actually Cl2. Go to your table, look up chlorine. Chlorine is 32.45. 32.45 times 2 gives you a molar mass of 70.9 grams, which is the equivalent of 1 mole. Or, said vice versa, you could do 1 mole on the top and 70.9 grams on the bottom, depending on the usage for the question coming up later. Now, compounds get bigger numbers, but the process is still the same. So the first thing you need to do to be successful is you need to write the correct chemical formula. So sodium carbonate's the first one I've given you an example of. In that compound you have 2 sodiums. So look at your table, that's 2 times 22.99. You have 1 carbon, so 1 times 12.01, and 3 oxygens. Oxygens is 16.00, and you add it up and you get 105.99. The mass then would be 105.99 grams for every 1 mole of sodium carbonate. The second example, CH3COOH, contains a grand total of 2 carbons, 4 hydrogens, and 2 oxygens. So periodic table values again, 2 times 12.01, 4 times 1.01 for hydrogen, and 2 times 16 for oxygen. Carbon, hydrogen, and oxygen are the most common elements on the table. If you would prefer your table, you could even go up to hydrogen where it's actually 1.008 and write it right on there. At 1.008, 2 places, that 8 would round that up to a 1. So hydrogen is going to be, for the rest of your life, 1.01. And use that number. When I was in school, it was 1.0079, depending on how the author of the table writes it. Grand total of 60.06 grams per mole. And then the last compound here is ammonium phosphate. So it's very important that you understand that there's 3 nitrogens, 12 hydrogens, 1 phosphorus, and 4 oxygens. And I think you should be able to do all this in your head, not your head, in your calculator. Once you write down 14.01 times 3, in my humble opinion, you should be doing this on the sheet of paper in the corner, if it's a small calculation. And then I don't think you should have to write these numbers down. You should be able to do all that in your calculator and come up with this answer at the bottom without showing all that work. I'll do it for the first questions, of course. But as you get faster at these, it's important for you to be able to look at numbers up on the table, and once you get them written down, use your calculator to its full capabilities. So 3 times 14.01, 12 times 1.01, 1 times 30.97, and 4 times 16. Add them all up. That gives you the mass of 1 mole of that compound. Let's do 5 examples that are in the next page in your booklet. We'll do them here from scratch. The biggest issue with these questions for most students is writing down the chemical formula correctly. If that's wrong, everything is wrong. So the first one is sulfur dioxide gas. So sulfur dioxide gas. Prefix di means it's molecular. Sulfur, so that should be sulfur trioxide gas. I want to change that to a tri to make it match the calculation I have in front of me so I don't bugger up the math. Sorry, sulfur trioxide gas. So again, prefix di or tri would indicate molecular. This is actually SO3 for a chemical formula. I put the stating because I knew that as a gas. Now, for my question, my requirement, let's say, is to find the molar mass, then that's a clue that I want to know what the mass would be for 1 mole of that substance. Now, sulfur trioxide is made up of molecules because it's molecular. So I need to go to my periodic table, look up the formula for 1 sulfur and 3 oxygens. This is where you're probably going to give me the stink eye, but I'm going to do it anyway. On your periodic table, the mass of sulfur is 32.06. I want you to change that number on the table to 32.07 because all of the answer sheets that I'm going to give you and all the questions that I'm going to give you are based on 32.07 that it was a couple years ago, and I have not gone back to change all the values. So you're going to work with me. Just as easy for you to change that number. It'll probably go back to 32.07. It was 20 years ago. It'll go back maybe eventually anyway. That's lame, but you're going to have to do it. Oxygen, 16.00. Multiply that by 3. So 32.07 plus 16 times 3, that's going to give you a grand total, do all the math, of 80.07. Now, no number is valid without a unit. That means that the mass of sulfur trioxide for 1 mole is 80.07 grams. To write that properly, it's either grams per mole with a slash. I certainly prefer to write it as a fraction, so your conversions will work. 80.07 grams per 1 mole. And that's the molar mass of sulfur trioxide gas. Second one, cuprous dichromate. Cuprous dichromate. So it's an ionic compound. Cuprous is copper 1. Dichromate is a polyatomic anion, Cr2O7, with a 2 negative charge. When you balance your compound, you need a 2 for the subscript of the copper and a 1 below the dichromate, and that will balance, no need for brackets. And there's your balanced equation. Cu2 Cr2O7. So to figure out the overall mass of the entire compound, you have to know the individual masses for each atom. So first of all, copper. There are 2 coppers. So 2 times your table, it is, when you round, copper is going to end up being 63.55, 2 chromiums, 52.00, and lastly 7 oxygens, and oxygens as an atom are 16.00. When you add it all up, you can see this is going to be a much heavier compound than sulfur trioxide gas. And in total, it comes to 343.10 or 343.1 grams for 1 mole. So if you were asked to go to the lab, pick the bottle that was labeled cuprous dichromate, and you want it to have 1 mole in your experiment, you would have to weigh out the equivalent of 343.1 grams on a scale to be equivalent to 1 mole. Number 3, cobalt 2 chloride hexahydrate. So we have a multivalent metal, cobalt 2 chloride, and we have a hexahydrate. The first level of success in chemistry will involve you writing the correct chemical formula. So cobalt 2 is CO2+. Chloride is a Cl1-. Crisscross, balance your charges. That's going to be COCl2. Now the hexahydrate, hexa means 6, that would give you 6 waters to balance or put in your chemical formula. Now this is a hydrate, and you should remember the definition of a hydrate, and that is that there are 6 water molecules chemically bonded to the crystal. And that requires you to calculate the mass of all the water along with the cobalt and the chlorine. So 1 cobalt, that's going to be, look your mass up of cobalt, 58.93. 2 chlorines, chlorine's 35.45. You do these separately if you want to. Do the 2 times 35.45 you want. Get your 70.9 and add a 2 and add a 2. But this stage you should be proficient with your calculator. The next thing, you've got 6 water molecules. So 6 water molecules is going to actually be 12 hydrogens. So 12 times 1.01. And 6 waters is going to be 6 oxygens. Be careful with your math skills, not to miss anything. So oxygen is 16.00. When you add that all up, of course, because there's water molecules chemically bonded to the compound, it's quite heavy. And again, this is going to give you a grand total of a large amount. And the answer I have in front of me is 237.95 grams of cobalt 2 chloride hexahydrate in the equivalent of 1 mole. Number 4, lead 4 sulfate. So lead is a 4+. Sulfate is a 2-. SO4 2-. This is one of those rare scenarios where both of the charges are even. So if you crisscross, you'll have to reduce. Or you can use your basic math skills and recognize that you're going to need 2 sulfates to balance the 1 lead, or you could have a 4 and a 2 and reduce it down to a 1,2 at the end. Anyway, the compound formula for lead sulfate is PbSO4 taken twice. That means you need 1 lead. And 1 lead atom is heavy, 207.2 AMUs, or 207.2 grams per mole of lead. We have 2 sulfur atoms, and again, we're doing funky Christie chemistry, so we're going to use sulfur as 32.07 because you are humoring me, and 8 oxygens, so 8 times 16.00. When you add that up and get a grand total, this is going to work out to a mass heavier than the previous examples, and it comes out to be 399.34 grams in 1 mole of lead 4 sulfate. And last but not least, on your exercise, you were asked to find the mass of oxygen gas, the molar mass. Well, the only hard part about this question is recognizing that oxygen gas is O2, a diatomic. So the mass of oxygen gas is actually double the mass of the single atom. So the molar mass of oxygen gas is 32 grams per mole. Or the equivalent, you could say, for 1 mole of oxygen gas, you would need 32 grams. And both of those would be correct. You could do this as well. You could say 1 mole of oxygen is the equivalent of 32 grams of oxygen. Or you could write it vice versa and say, if you had 32 grams of oxygen, you would have the equivalent of 1 mole of oxygen. And they're the same thing. One's written, so the moles will cancel. The first one on the left. This one is written, this version of the molar mass is written so the moles on the bottom would cancel during a calculation. And the second example is written so that during a calculation, the grams would cancel, being on the bottom. Hope that helps you to understand how molar masses are calculated, and there'll be lots of practice in your booklet for you to work on to hopefully nail this down. The hardest part for most students is writing the correct chemical formula. Be very, very, very careful on your calculator. Not a bad idea to do each calculation twice and double check it. 99% of all errors in Chapter 8 come from a sloppy molar mass calculation. So make sure you write down the right numbers from the table. Make sure you write down the right numbers in front of each of your elements, and then the rest comes down to proper calculator usage. So good luck with that.